Okay, so for this first example, we have this former mechanism. We want to solve for the instantaneous velocity VC and VCB when the angles theta 3 and theta 4 are given, and AB is rotating clockwise at 1 radian per second. So the angle theta 2 is also given, no? And also the R's, no, the lengths. So R1, R2, or sorry, it should be R2, R3, R4, and R1 are given. Theta 2 is given. So actually, this is the same example as before for the position analysis. We just want to solve now the instantaneous velocity VC and VCB. So basically, your VC here is VC here is this, no, this in this direction, and then this is your VCB. This will be your VB, no. Okay, so how do we solve for that? So let's say for we already have a formula here. So to solve for VC, you have R4 omega 4, right? So to solve for that, we need to solve first for omega 4. So solving for omega 4, we already have a formula here. So is it everything given, no? So omega 2 is given. So this is omega 2, guys. I'll just write down here omega 2. Okay, so we can solve this. You have omega 2, so 1 times R2 over R4. So 25 R2. R4 is 45. And then you have sine theta 2. So theta 2 is 120 minus theta 3 is 22.84. And then all over sine theta 4, so 98.95 minus theta 3. So you have 22.34. Yeah. So you have 0.5659 or for 566 na lang, no? 0.566t, no? So this is in radian per second. So therefore, if you want to find BC, this will be just R4, no? So this will be just R4 and omega 4. So R4 here is 45. So 45 times 0.5660. So the answer should be 25.47. 25.47. So the unit should be in centimeter per second. No? So how about VCB? So for VCB, that is R3 and omega 3, no? Multiplied by omega 3. So VCB here, we already know R3. For omega 3, we want to solve first for omega 3. So for omega 3, you have this as your formula. So you have one, sorry, I just manipulate this one. No? It's hard to manipulate. We might make a few mistakes. So let's just write this down again. So 25 over 60. Then you have sine theta 4 is 98.95 minus theta 2. So that is 120. Then sine theta 3 minus theta 4. So theta 3, 22.34 minus 98.95. So the answer should be 0.1538. 0.1538. So this is in radian per second, no? So therefore, your VCB here, multiply this R3 by this. So I'll just use ANS to make this a bit quicker. So omega 3 is 0.1538 times 60. So the velocity is 9.23 centimeter per second. Okay. So an alternative way to solve this is actually using the the vector, no? I won't be delving into that, but you can try. It should be the same as this. Okay. So that's it for example 3.